The topic is finding absolute extrema of functions of two variables. So let's read the definition. To find the absolute maximum and minimum values of a continuous function f on a closed bounded set D, first we find the values of f at the critical point of f in D, and then 2, we find the extreme values of f on the boundary of D. Then the largest of the values from 1 and 2 is the absolute max value, and the smallest is the absolute min. Alright, so let's do this example. Find the absolute maximum and minimum values of f of xy equal to xy squared on D equal x positive, y positive, x squared plus y squared less or equal than 4. So in other words, x squared plus y squared less or equal than 4 is a disk, right, with radius 2, but we don't want the whole disk. Disk will be inside this circle, but we want x and y to be positive, so we only need this quarter disk, right? Alright, so first let's find the values of f at the critical point. How do we do that? We first calculate partial derivative with respect to x of the function. Our function is 2xy squared, so partial derivative would be 2y squared. Partial derivative with respect to y will be 4xy. We're supposed to set them both equal to 0 and then solve the system of equations. This tells us that y squared is 0, which means y is equal to 0. Plug it in here. Y is equal to 0, which means x. Yeah, y equals 0, but x could be anything, right? Because 0 times 4x times 0 will give you 0, so x could be anything. However, we know y equals 0 means what? We're on this boundary, so we don't care. When we do 1, in other words, when we find the values of f at the critical point of f, we're looking for points that are inside the region, anywhere inside, not on the boundary. Number 2 is the one that take care of the boundary. So here we say, since y equals 0 means no critical points inside D. And then we move on to the boundaries. These 3 boundaries. Let's call this L1, and let's call this boundary L2, and let's call this boundary L3. Alright, so let's start with N1. On the boundary L1, what is the equation of the boundary L1? We know that y is equal to 0, and we know that x is between 0 and 2. By the way, first thing, like I did in the previous examples, I'm going to treat this corner point first. So this point is 2, 0, this point is 0, 2, and this point is 0, 0. So I need to evaluate f of 0, 0, f of 2, 0, and f of 0, 2. Alright, so that's why I'm not going to use equality here. So x is strictly between 0 and 2. So what would be, and now we need to evaluate the function at the boundary. So z will be equal f, x can vary, but y is equal 0. And this is equal, whatever we see y, we plug a 0 into our function. So this will be 2 times x times 0 squared, which is just 0. Now, derivative of z with respect to x, to see if there is any critical numbers, it's equals 0, which means no critical numbers. Alright, now let's move on to the boundary L2. On the boundary L2, the y will be equal. Remember that the equation x squared plus y squared equal 4, right? The equation will be x squared plus y squared equal 4, so we need to solve for y. This means y squared is equal 4 minus x squared, which means y is equal minus or plus square root of 4 minus x squared. But since y is positive, see, y is positive, therefore, well, let me write it here. Therefore, y is equal square root of 4 minus x squared. And then my x is between 0 and 2 again, strictly. Alright, now we need to find the value of this boundary, of the boundary L2. So we plug in, so z will be what? F of x can vary, but the y happens to be this quantity, square root of 4 minus x squared. How do we get that? We plug in square root of 4 minus x squared into the y, into this y. So z will be equal 2x square root of 4 minus x squared, which is 2x 4 minus x squared, right? This is minus x squared. Alright, so now dz dx should be equal to, well, let's FOIL this one. That would be minus 2x cubed plus 8x. So dz dx will be minus 6x squared plus 8. We set it equal to 0 to find critical number. Yes, x squared will be equal minus 8 over minus 6, which is 8 over 6, which is 4 over 3. Now x will be equals minus or plus square root of that. But we know x is positive, right? X is between 0 and 2 actually. So we only pick the positive one. So x will be equal 2 over square root of 3. Now how do we find the value of y? We need to plug it into here. So therefore, y will be 4 minus x squared square root, which is equal 4 minus 4 over 3 square root. Now this is going to be 12 minus 8. 12 minus 8, 4 over 3 square root. Right? 12 minus 4, no, 8. Alright, so our next point will be, so we need to evaluate f of the x is 2 over square root of 3. The y is square root of 8 over 3. Now on the last boundary L3, on the boundary L3, what do we know about the boundary L3? We know that x is equal 0, but y is between 0 and 2. This means that z will be equal to what? If we plug a 0 there, we'll get z equals 0. Now dz dy is equal 0, which means no critical numbers. So we're done now. All we need to do is plug in all those points. So f of 0, 0 will be 2 times 0, 0 squared. That's 0. F of 2, 0 will be 2 times 2 times 0 squared, which is 0. F of 0, 2 will be 2 times 0 2 square, which is 0. And then this will be 2 times 2 over square root of 3 times square root of 8 over 3 squared. Now this is going to be equal 4 over square root of 3, 8 over 3, which is 12 over 3. Let me do it in two steps. 12 over 3 square root of 3, which is 4 over square root of 3. So the smallest one will happen in, so the absolute minimum value is equal 0, and it happens at this point 2 0 0 0 0 2, and the absolute maximum will equal 4 over square root of 3, and it happens at the point 2 over square root of 3 square root of 8 over 3. And that's it.